morning, everyone. A very good morning. Shall we begin the session? Yeah, today's topic is a new topic, that is a revision of the computer system. In the last class, we have finished with a revision of the quality system in IT. Now, today I'm going to present, or today I'm going to deliver a new session, that is a revision of the computer system. So let's start with the introduction of the computer system. What is the computer system? How it is developed, and what are the various drawbacks that is used with the computer system that we can see. So what is a computer? First of all, that takes the input, that processes it according to the stored instruction. So whatever the instructions, whatever the data that is given in the processing, or that is given in the data, so that takes the input. So computer takes the input, processes it according to the stored instruction, and produce the result as the output. So first of all, it takes the input, then process it according to a stored instructions, and produces the result as the output. Now, what are the various key concepts that is used in this? One is the input, that is the data, then instruction that includes the software and the programs, and output that includes the information. That may be numbers, that may be words, that may be sound, that may be images. So first of all, there is a computer that takes the input, then it processes it according to the stored instructions, then produces the result as the output. Now, what is the input? That is the data. Then instructions, that is the software and the programs. What is the output? That is the information. That information may be numbers. The information may be word. The information may be sound. The information may be images. Now, what are the various types of computer that is available? One is a special purpose computer. One is a general purpose computer. And special purpose includes the embedded system, and the general purpose includes the user program. Now, special purpose is again divided into multiple parts. One is a pre-programmed. General purpose includes that can be adapted to many situations, to many scenarios. That may be a watches, that may be engine management, that may be a telephone, that is a traffic signals, television, navigation devices. Then general purpose computers includes personal computers, mainframes, that include the workstation and the supercomputers. Now, data versus information. What is the data then versus the information? When I take about this one, 2, 4, 23, this one, this is known as the data. When I say this is your grade in the exam, this is the information. Why? Because I'm saying that this is your grade in the exam. Whatever you score in the exam, that is your grade, that is A. In the same way, next week's lotto numbers, whatever the lotto number that is available, that is used as a 2, 4, 23, 30, 31, 36. That is the information. Now, what are the various key concepts? One is the codes. So data and the information can be represented as electronic signals. So whatever the electrical signals, whatever the data that is available. For example, when I say there is a Morse code or there is a Morse signal, that is also known as the code. So whatever the data and information that can be represented as an electrical signal. And what is a code? It is a set of the symbols. Symbols means set of the dots, dashes, whatever that is available in the Morse code, that represents another set of symbols, such as the letters of the alphabets, integers or the real numbers, light in an image, or for the tone of an violin. So whatever the image, whatever the letters, whatever the integer, whatever the real number, whatever the light in an image, that is used with the data, that is used with the information, that is used with the electrical signals. Next, what is a circuit? When I combine multiple electronic components in a, we can say, smooth function, that is known as a circuit. So it is an interconnected set of the electronic component that performs a function. Then ICs, that is a combination of the thousands of the circuits built on tiny pieces of the silicon known as a chips. So what is a chip? That is an integrated circuit that contains thousands of the circuit built. Then next is the binary signal. So there are two state signals. One is the data with the two states of and on, low voltage, high voltage, then 0 volt and 5 volt. Then bit. So this is a single binary digit, that is either 0 or 1. And this is the smallest possible unit of information in a computer. Whatever the possible input, whatever the smallest possible input that is available, that is known as a bit. So it is the smallest possible unit of information in a computer. The next is group of bits, that is also known as the information or the data. 1 bit is equals to 2 alternative, either 0 or 1. Then 2 bits, 4 alternatives. Then 3 bit, 8 alternatives. In the same way, 4 bits, 16. So that means if there are n bits, so there are total 2 to the power n alternatives. And if there are 8 bits, so there is a 2 to the power 4 or 2 to the power 8, that is 256 alternatives. and group of the 8 bits is known as a byte. So what is a byte? It's a collection of the 8 bits. So these are the various representation of the 4 bits. There is a 0000, then 0001, 0010, then 0011. In the same way, 0100, 0101, 0110, 0111, then 1000, 1001, 1010, 1011, 1100, 1101, 1110, 1111. So these are the various combination of the bit that is available, and if there are 4 bits, that means there are total 2 power 4, that is 16 combinations. So if you count the 4, 4, 8, 4, 12, 4, 16. Now, next is the key concepts. What is the information system? So first of all, it is a system that takes data, stores and processes it, and provides the information as an output. This is the data. This is the system that takes the data, whatever the data they takes, how they store, how they process, and how they provide the relevant information as an output. Then an S is a computer in use. Then amount of the data can be vast. So whatever the amount of data that we can use, that can be vast data, that can be huge data. Now, next is the communication system. So communication means the transfer of the meaningful information. So whenever we transfer information, whenever we collect the data, that is known as the communication. So that comprises, one is the sender that sends the data, transmitter, channel over which to send the data, so or by which, or the channel by which we can send the data, then there is a receiver. Then there's a network. Whenever I combine multiple computers together, that is known as a network. So two and usually more communication devices connected together in many connection topologies. Now next is the hardware and the software. What is the hardware? What is the software? So hardware is a physical parts of a computer that we can touch, that is known as hardware. Then software, the program that controls the operation of the computer system, that is known as software. So one is a hardware, that is a physical component that we can touch, that we can use, that is the physical component, physical part of the computer or the information system. Then software, the program that controls the operation of the computer system, that is known as the software. That means whenever we build the software, whenever we build the hardware, then internal components for the data that is available, that is known as a software. Now these are the components of computer system. What is the keyboard? Then display, then system unit, storage, and the printer. So keyboard means by which we can type the character, that is an input device. Then display, that is a monitor screen on which we can use the display, by which we can represent the information on the screen. Then system unit, that is a CU or the CPU, by which everything is stored, on which everything is controlled. Then there is a storage. Storage means whatever the data, whatever the scenario that we are using, so that the data will be used as a storage, or the memory that we can use in the storage. Last is a printer, that is used to convert the hard copy, soft copy into the hard copy. Now, next is the key components, more formally input, output, storage, and the processes. First of all, we have to give the input, then the storage will be done, then processing will be done, and at last there is the output that is generated. So this is the input, this is the input, this is the storage, processing, and the output. Now, this is the input system. One is the keyboard. So this is one of the most common input device, and the most common keyboard name is QWERTY keyboard. Then input system, mouse, there is a cursor manipulation device. This is a trackball that is used within the mouse, that is available within the mouse. Then touch screen, this is the touch screen, that is the input keyboard mouse touch screen. Now next is the laser pen or the pens, stylus, whatever we are using. Then there is the touch screen, stylus we have done. Then MICR. This is magnetic ink character recognition. So whatever the characters we recognize, whatever the tool that we recognize within this check, for example, this is recognized by the MICR, that is magnetic ink character recognition. Then barcode readers, that is also used to read the barcodes. Then optical character recognition, that is used for the book reader for the blind, automatic input of the text, and can do the typewritten text in the handwritten block capitals, and the problems with the cursive handwriting recognition. Then sensor, this is a digital thermometer, accelerator, strain gauge, that is a weighting scale that is also used as a sensor. Then camera system, that is used for the monitoring, visual inspection, robot guidance, video conferencing. Then voice, this is the voice recognition, hands-free car phones, assistant for the disabled. So these are the input, storage, output processors. So input is done. That may be input device, that may be keyboard, that may be mouse, that may be joystick, that may be scanner, anything that you want. So there are multiple devices, multiple input devices that is used with the computer system. So one is the input, then there is a output, then there is a storage, then there is a processor. Now, what are the various output that we can use? So one is a soft copy. Yes, one is a soft copy, one is a modem, one is a disk or tape, one is a hard copy. Now, soft copy, that may be a voice synthesis or the voice recognition system, that may be music, that may be CRT, that is a cathode ray tube, that is maybe LCD, that is a liquid crystal display. So this soft copy is divided into multiple parts. That is a voice synthesis, that means how the voice will be modulated, how the voice will be circulated. Then music, how the music will be stored, how music will be activated. Then CRT, that is a cathode ray tube. Then LCD, liquid crystal display. So CRT, that means the CRT display will be used. Then the liquid crystal display will be used for the output system. Now, next is the modems. What is the meaning of modem? Can anyone tell me what is a modem? Yes, modem stands for modulator and the demodulator. That means conversion of the analog into the digital signal is done by the modem, and the conversion of the uh, digital signal into the analog, that is done by the demodem, that is a demodulator. And this also allows a computer to communicate over the telephone lines. How to use over the telephone line? That is used with the output system, that is used with the modulator and the demodulator. The next one is a disk or the tape. So whatever the data, whatever the disk, whatever the magnetic devices we are using, that is known as the disk. That may be a magnetic disk, that may be a digital disk, that may be floppy or the hard disk, that may be optical disk, that may be storage device. The next one is a hard copy, that may be represented with the help of the plotters, that may be represented with the help of the microfilm, non-impact printer, and the impact printer. So the hard copy may be a plotters, hard copy may be a microfilm, on microfilm, that may be a non-impact printer, that may be a impact printers. Yes, we want the hard copy, that may be a printer also. Yeah, printer is again divided into two parts. One is the impact printer, one is a non-impact printer. So this is a plotter, one of the example is plotter. Then next one is microfilm. This is one of the example of the microfilm that is available. Now, these are the various non-impact printers that is used. One of the non-impact printer is laser. There is no impact on the printing, magnetic, thermal transfer, thermal and the electrostatic. So these are the various categories of the printer. One is a laser, one is a magnetic printer, one is a thermal transfer printer, one is a thermal and electrostatic printer. Now, next is the impact printer. One is a dot matrix that represents a dot at the end of the line. And this prints line by line. That's the dot matrix and the line print. Now, next is the storage. We have done with the input. We have done with the output. No. We're not done with output. Yeah, we are done with the output. These are the various output devices. So we have done with the input. We have done with the output. These are the various output devices. One is a soft copy, then modem, then disk or the tape, then hard copy. Again, the soft copy is divided into multiple parts, that is voice, CRT, and the flat panel. Then the hard copy is divided into multiple parts, that is the plotters, microfilm, non-impact printers, dot matrix, and the line printer. Next one is the storage. How the storage will be done? First is the temporary memory, then permanent mass storage. Temporary means we can say once the data is written, then it is again safely removed. That is, there is no hard and fast rule that it is again stored. Well, it is a temporary memory. We cannot store the for the permanent. For example, there is a cache memory in which the data is stored on temporary location or as a temporary location. Then permanent, for example, when I am talking about the hard disk, that is known as a permanent storage or the permanent mass storage. So this is a 1 bit, then 1 byte equals to 8 bits, then 1 kilobyte equals to 1024 bytes, then 1 MB equals to 1024 kilobyte. Then temporary memory is again divided into two parts. One is the ROM and the RAM. So first of all, there is a memory that stores the bits and the byte, instruction and the data. Then ROM, that is read-only memory. This is non-volatile, won't disappear when the power is off. Then there's a RAM, that is random access memory. This is read-write memory. This is volatile in nature, and there's the single inline memory modules. And the 4 megabytes in a stick of the chewing gum. So ROM is non-volatile in nature and the RAM is volatile in nature. Won't disappear when the power is off in case of the ROM, and in the case of the RAM it will disappear. Then again there is the storage system, optical disk, 15,000 tracks per inch, digital code, read by the laser, 650 megabytes in a 4.75 plastic laser. Then CD-ROM, this is the compact disk read-only memory. Then WOM, that is write once, read many time. Then erasable disk. Then CD-ROM, this is read-only memory, 12 centimeter optical disk. This is capable of storing 72 minutes of VHS or the VHS quality video using MPEG compression. Now next is a WOM, that is write once, read mostly times or the mostly CDs. This is powerful laser burns into the digital codes. Then there is a not erasable. So this is not erasable. Then the lower power laser reads the digital pattern. So whatever the digital pattern that they are using, this lowers the power laser that reads the digital pattern. The next one is erasable CDs. This laser read and write the information. Also use a magnetic material. So this also use, or the erasable CD also use a magnetic material. And to write, a laser beam hits a tiny spot and magnetic field that is applied to reverse the magnetic polarity. Next is the magnetic disk. So this is a circular platter coated with the magnetic material. This is the magnetic disk. Then floppy disk, this is 3.5 360 kilobyte to 2.88 megabyte, that is 1.44 is common. Then hard disk, that is of the capacity, different capacity, for example 1.3 inch, then 1.8, 2.5, 3.5 and 5.25. The next one is a storage systems. Again, there are new storage system that is available. Now the next part is the 40 GB hard disk, that covers basically 20 lakhs pages of the text. And then the 650 megabyte CD, this is 325,000 pages of the text. Then 70 gigabyte DVD, that is 85,000 pages of the text. So these are the multiple texts, these are the multiple storage devices that is available with this. The next one is the storage system, that is the height of read head about the magnetic storage. This is about the 2 millionths of an inch. Then there is a smoke particle that is about 250 millionths of an inch. Then fingerprint, this is about 620 millionths of the inch. Then dust particle, this is about 1500 millionths of an inch. Then human hair, this is about 3000 millionths of an inch. बंद कर देना. Now, we have done with the input, we have done with the output, we have done with the storage. Next part is the processor, that may be a hardware, that may be a software. Now, these are the various components of a computer system. That may be, first one is keyboard, then display, system unit, storage system, and the printer we have done. Right, again this is used with the processor. One is a hardware. There's a microprocessor. This is the effect on the computation. Whatever the effect that we are going to study, there is an impact on the computation that is dealt with this. Now the microprocessor contains the effective computation or the effect computation. Then there's Intel. This is 80486. Then 80586. This is a Motorola. This is one example. Then PowerPC, MIPS, Alpha, Sparks. Then there's a clock speed of the 50 to the 600 megahertz. And after this, there is a memory that includes a storage. Storage means in the sense how we can include or how we can store the data in the storage. The interface IC, that is the integrated circuit, so there is a communication with the other devices also that is included. Now, what is the hardware? This is much more to common or much more to come on the topic of the hardware shortly. Now, this is a software that includes, or what is the software? That is a set of the programs. Now, the software is divided into two parts. One is application software, one is a system software. And the system software is divided into two parts. One is operating system, one is a programming language. And the operating system means whatever we are done, whatever we are going to study, that is known as a system software, that is known as operating system. One is application software. There is a general purpose computer and the special purpose computer. The software is divided into two parts. One is system software, one is application software. Then system software is divided into two parts. One is a system operating system, one is the programming languages. And the application is divided into two parts. One is a general purpose computer, one is a special purpose computer. Now, next is the operating system. We have done with the software. There are two types of software. One is the system software, one is the operating application software. And the system software is divided into two parts. One is the operating system, one is the programming languages. Now, let's see what is the operating system. So first of all, it is an interface between the user and the hardware. Now, what is the interface? That means a software which is responsible for passing the information to and from the person using the program. Whatever the information, whatever the tool that you are going to study, that is responsible for passing the information to and from the person using the program, for example, user. The next is that communicates with and control the system. This is the user interface. And there are three types of user interfaces that is used. One is a graphical user interface. One is a menu-driven interface. One is a command-driven interface. So, a graphic user means, for example, we are using the Windows. That is a graphical user interface. We are using the graphics by which we can study the concept, by which we can study how we are going to build, how we are going to access. Then menu driven means a menu is generated for various tasks and we have to choose the option from the menu. Then the command driven, for example, DOS, Linux, that is a command driven. We have to give the commands in the interfaces and type the errors. Now, first of all, there is a graphical user interface. This is used by representing the pictures, graphic symbols, icons to represent the commands. Then there is a Windows, a way of looking in on several applications at once. That means whatever the application that is using, that is used with the Windows, that is used with the operating system. Now, next is the menu-driven interfaces. There is a menu bar, pull down menu for the sources. The next one is a command-driven interface. So there is a system prompt. User types in single letters, word, line, which is translated into the instruction for the computer. That means user have to select, user have to write down the names. For example, when you save the CP, that means a copy the source destination. Needs to be very familiar from the syntax of the command language. Now we have done with the operating system. Next is the programming languages. No. This is again the slide of the operating system. This is a software that manages the overall operation of the computer system. Overall operation means whatever the kind, whatever the scenario that we are using, everything is controlled, everything is managed by the operating system. And the main purpose is to support application program. So this is the main purpose, that is to support the application program. Then hide the details of devices from application program. So this is used to hide the details, or we can say the remove the details of the devices from application program. Next is the operating system. Again, there is a kernel that is divided into multiple parts. One is a shell, one is a network interface, task scheduler, and the kernel. Now, shell is a user interface. Network interface is a coordinate multiple tasks in a single computer. Then task scheduler, this is the coordination of the multiple tasks in a single computer. Then kernel, that is software which ties the hardware to the software. Then kernel also manages the flow of the information to and from the desk, printers, keyboard, and other input-output devices. Now, first is the file handling. This is the collection of the information that is stored on a disk. The disk need to be formatted to allow them to store the information. Operating system manages the location of the files on a disk, and also OS also performs input output to the disk. OS checks and corrects the errors on the disk input output. There's a device driver, that is a program which handles the various hardware devices, for example mouse, keyboard, CDs, video, etc. For example, if I'm talking about an application that wants to print a document, it calls the operating system, which sends the information to the device driver together with the instructions. Whatever the drivers, whatever the instruction that is given, so that is supported by the device drivers, and the printer driver handles all the controls of the printer. Then operating system is again divided into two parts. One is a single tasking operating system, one is a multitasking operating system. And if I'm talking about the single tasking, that means only one application is running at the same time. This means runs only one application at a time, and the multitasking means more than one application can be run or can be active at any time. So more than one application can be active at any one point of time. Now, next is a DOS, that is a disk operating system. It is a single tasking operating system. It is a command driven. That means we have to give the commands. Then huge number of applications written for the DOS, the multiple application that is written in the DOS only, that does not require the powerful computer. This does not require the powerful computer, only the normal computer is available or is used for the DOS. Then no network services. So there is no network services, that is again used for the operating system. Then no multimedia extension. There is no multimedia extension that is given for the operating system. The next is designed for the Intel 80x86 processors. The next one is a Windows. Now, this is again opposite of the DOS. So Windows is a GUI, that is a graphical user interface, can run the DOS programs and has a network services. One of the main concepts that is used is the network service. That means this operating system that is known as a Windows has a network services that is used with the operating system. And this also requires a large amount of memory, disk space, and the powerful processor. Then designs for the Intel 80x86 processor. The next is Macintosh operating system. So one is a DOS, one is a Windows, next one is a Macintosh operating system. This is for the use for the multitasking. GUI called Finder, very easy to use, very graphically oriented, has a network services, multimedia extensions, designed for the Motorola and the PAF PC processors. Next is the special purpose computers or the special purpose software, application software. One is a payroll. Now, general purpose we have done. No. Now, What is a general purpose computer? That means we are using the computers on a single tasking or the multitasking operating system. The next one is a DOS. So that is used for the single operating system and can also run a DOS programs and has a network services. The next one is a Macintosh operating system. That is a multitasking operating system that supports whatever the tools, whatever the scenario that we are given. That means basically it is a GUI operating system. And it is very graphical oriented. That means we are using the operating system on a graphical format that is available in a graphical format. Then next one is operating system that is a Windows. This is a GUI and can run the DOS programs, has a network services. Then there is a multimedia extension that is used with the operating system. Then this also requires a large amount of memory, disk space, powerful processor. And this is designed for the Intel, this one. Then Macintosh we have done graphically oriented. Now special purpose means that is specially used for an application. For example, if I'm talking about the payroll, if I'm talking about the accounting, if I'm talking about the bookkeeping, if I'm talking about the entertainment, statistical analysis. These are the special purpose computer that is available for the data that is used with the data. No, general purpose means normal that we are using. Special purpose that is used for the, for example, payroll is used by the accountant and the accounting is used also by the accountant. Bookkeeping that is used in the store purchases. Then there's entertainment that is also used for the entertainment purpose only, movies, statistical analysis. Then the special purpose means that is used for the special purpose. Sorry, general purpose means that is used for the generally. For example, word processing, MS Word, desktop publishing, that is Quark Express, then spreadsheets, for example, MS Excel, database, Access, graphics, PowerPoint, email, MS email, internet browsers, that is the Firefox or the Explorer. So these are the various general purpose computer that is used over here. So one is a word processing, that is for example the MS Word we are using, then the desktop publishing, MS Excel, MS Access, MS PowerPoint, MS email. That is means email that we are using. And the internet browser that means the same, Firefox, Mozilla or the Chrome. So we have done with the application software. There are two types of application software. One is a general purpose, one is a special purpose. And next one is the integrated software, and the goal is to make effective sharing of the information between all the computer. That means whatever the application that we are using, so the main goal is to use or the sharing of the information in an application. For example, when I am talking about the Word, Excel and the PowerPoint, so this can access all users, that means they are using obviously. Then at last there is a term that is used with the OLE, one is object link embedding. And in this the information is stored in one location only. That means everything is available in one location, that is used in the one location only, and the reference is made to it from another application, whatever the another application that is available with this data, and this reference is known as a link in the sense we can say this object is used as a link for the other object, that is OLE, object linking and embedding, and don't actually copy a data, but it is using the hypertext, it is using the multimedia or the www. Now, can anyone tell me who is the father of www? Yeah, full form is World Wide Web, but who is the father of www? Tim Berners-Lee is the father of the www. Yes, and the full form is Worldwide. The next one is application software, that is OLE, object linking and embedding. Then operations of the processor and the memory, whatever the operation that we are dealing with, that is the operations of processor and the memory. Then what is the processor? This is the functional unit that interprets and carried out the instructions, and also known as a CPU, central processing unit. And every processor has a unique set of the operations that includes the load, that includes the add, that includes the store. And whatever the set of the operation that we are using, that is known as an instruction set, also referred as a machine instructions, and the binary language in which they are written out, in which they are used, is known as a machine language. And the instruction also comprises the operator, operand, that means on which the data is operating out. For example, if I'm talking about the add operator, that requires the two operands, what the two numbers are and where the two numbers are. And the processor, if the data, the number is to be added in a memory, then the operand is known as the address. That means add the num1 and the num2. And num1 could be a number, or it could be the address of a number in the memory, that is where the number is stored. Either it could be a number, direct number, or either it could be address of a number in the memory. Then this is one of the example. This is a machine language instruction set. One is arithmetic, that is add, subtract, multiply, divide. One is a logic, that is and, or, not, exclusive, or. So one is the data movement, that is a move, load, store, then input output, that is either read or write. And the processor is, or the processor job is to retrieve the instruction from the memory, retrieve the data or operands from the memory, perform the operation, then maybe, or it may store the result, it may retrieve the result, or it may retrieve the next instruction. So whatever the data, whatever the scenario that is available, that is used with the step-by-step operation that is repeated over and over at speed measured in the millions of the second. And the clock governs the speed. Each step must wait until the clock ticks to begin. And the 300 mega processor will use a clock which takes 300, 100 times a second. The next one is the components of a processor. There is input, there is a memory, there is a output. So when is the input, then memory, then output, there is a CPU, and which there is control unit. Now, each and every function is very important in this one. Why? Because control unit control each and every operations of a computer system. Whatever the operation that we are dealing with, that is controlled by the CPU. And ALU, again, it is used as the arithmetic and the logical unit. Whatever the logical unit, whatever the data that is using, so that every calculation is performed by the ALU. Each and every calculation, that means that may be arithmetic calculation, that may be a logical calculation. Arithmetic calculation includes plus, minus, divide, multiply, that is addition, subtraction, division, multiplication. And the logical operators means less than, greater than, less than, equals to, greater than, equals to. Each and every operation is performed by the ALU. This is used for the, we can say simply, for the calculations, and the control unit is used for the controlling each and every operation in the computer system. Then registers, that is used for the storage purpose. So one is input, then memory, then output. This is the CPU, that control unit, arithmetic logical unit, and the registers. So if you see this processing, this is the input, this is the output, this is the memory, this is the control unit. Now, let's see what is a control unit. As I said, this supervises the operation of the processor. Whatever the operation that we are carrying out, whatever the tool that we are carrying out, so this operates the processing. So this operates the processing, that means whatever the capability that we are using. Then operating system or the control unit makes the connections between the various components. Control unit makes a connection, or it makes a connection between the various components, and it also invokes the operation of the each component. Each and every component is also invoked by the operations in this one. It can be interrupted. So control unit can be interrupted also. Now, what is an interrupt? That is a signal which tells the control unit to suspend execution of its present sequence of the instruction, that is a A, and to transfer to the other sequence, that is a B, Then resuming the original sequence when finished with the B. So resuming means shut down the sequence with the original sequence. Next is a interrupt. Then that is the instruction A1, A2, A3, A4, A5. Instruction B1, B2, and Bn. So this one is the execute the instruction, then branch to a new set of instructions. So what is a CU? This receives the instruction from the memory, decodes them. That means it is converted into the multiple bytes. Then breaks each and every instruction into the sequence of the individual actions. More on this later, that is available with this. And in doing so, this controls the operation. That means whatever the instruction that we are dealing with, whatever the tool that we are dealing with, that is used with the instruction, that is used with the individual events. And in so doing, controls the operation of the computer. The next is the ALU, arithmetic and logical unit. One is the ALU. This provided the computer with its computational capabilities. Data are brought down to the ALU by its control, by the control unit. Whatever the data that is required by the ALU, that is also provided by the control unit. ALU performs all the required operation. Whatever the required operation that is performed by the ALU. So one is the ALU. This provided the computer with the computational capabilities. Then data are brought out to the ALU by the control unit. Then ALU performs the required operation, whatever the mathematical logical calculation that is performed by the ALU. Now, what are the various arithmetic operations that is available? One is addition, then subtraction, multiplication, and the division. Then, what are the logical operations that makes the comparison? For example, CMP AB and take the action as a result. This is BEQ. Then registers, this is the storage location inside the processor. Then control unit registers, this is for the current instruction. Location of the next instruction to be executed. Then operand, that means there are two concepts. One is the operation, one is the operators, one is the operand. Operations means the data on which the operation is performed. Then operand means, for example, A and B are the operands and the plus is the operator. So this is the plus, that is the operator of the instruction. Then what are the various ALU registers that is used? So one is used for the storing the data items, whatever the data item that we want to store, then stores the result. Now, this is the word size or the word length, that is the size of the operand register. Also used to describe the size of the pathways from which it is used and the between the component. So, for example, if I'm talking about the 11001111, so that means this is the operand that is used for this. And this includes 16 to 64 bits, word length are common, and 32-bit register. So one is the DSP, that is the digital signal processors, application specific